Okay, now we're getting back to dehydration of alkenes, but now we have to look at it in like a stepwise manner. Remember, when hydrating an alkene, you need to have a strong acid present, like sulfuric acid or another strong acid, to break that pi bond, that double bond, right there in the CH2. It breaks the pi bond. And that's what that H plus is. That's a strong acid. That's the first step. Once that pi bond is broken into a sigma bond, you have CH3, CH2 plus. Now, the next step. This is where the actual hydration comes into play. So now we didn't even touch water. That hydrogen that occurred in the previous step, that H plus there, that was from a strong acid. Now, this is where water comes in. See, the carbon wants to complete its octet, this carbon here. So it binds to the oxygen, binds to that oxygen molecule of that water molecule. It binds to the oxygen atom of the water molecule. But now the water molecule is deficient. It wants to bind its octet. See, it's got a little plus there. So now the last step is, you see the CH3 bound to the CH2, and that's bound to the water molecule that has an oxygen that wants to complete its octet. So I initially stated, you can see a little bubble there, it says, not sure why the hydrogen gets kicked out here. Well, initially, when I first wrote this down, I forgot to write that plus there and the plus there, so I didn't know that the oxygen wanted to complete its octet. Yeah, kind of stupid. Okay, so here you see the hydrogen getting kicked out in the creation of ethyl alcohol. The hydrogen gets kicked out so the oxygen completes its octet with a lone pair. And then you have the formation of ethyl alcohol, and there's the proton. Pretty cool. I also made models of this. I had a model kit, and this is the stepwise one. This is it in steps. Here's your ethylene, C2H4. There's the double bond. Then we get, when that hydrogen, that proton, here's the proton, bam, kicked out, broke the pi bond, you get a sigma bond here, so you get CH3, CH2 plus. Now, the CH3, CH2 plus binds to a water molecule to complete the octet of this carbon. So yeah, this is the water molecule. That yellow sphere is the oxygen atom, and these, are two hydrogen atoms. Here, let me get a better look at it. Now, it might not be, the angles might not be right because, these little spheres in the model kit are kind of limited, they only have so many holes you can stick these little spring things into to connect them. Now, the last step is where you get the formation of the ethyl alcohol and the proton, which is represented, so I ran up hydrogens, which are the white bulbs, just got a little sticky note, H plus. And here's your ethyl alcohol, which is CH3, CH2, OH. Remember, this yellow bulb is oxygen, and the proton. Bam. Now, this all happened here. This kicking out of this hydrogen, of that hydrogen to make that OH instead of H2O, that happened because the oxygen wanted to complete its octet. Right here, you have a lone pair, picture an imaginary lone pair there, and a plus. So it gets rid of that hydrogen and takes on, now it has two lone pairs, bop, 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 and it's complete. And that hydrogen that was just kicked out is right there. So here's a little picture of all of them. See if I can get them all in one frame. Yay, there we go. Okay, and that's the hydration of ethylene.